Hey biochemistry students, for this example what we're going to do is a very similar reaction to the last example, except the difference this time is we're going to be using a strong base instead of a strong acid. So everything else is the same. We start out with a phospholipid, but we're going to be using then a strong base. So our strong base is going to be sodium hydroxide, NaOH, and we're going to be using water. HOH. And just like what we did in the last problem is we're going to be breaking these ester linkages. Okay, so we have an ester linkage here where we have the carbonyl group, double bond O and the oxygen. This is one carbonyl group. And here's another carbonyl group. And then here we have another ester linkage. In fact, we have two of them. We have an ester linkage here, like this, if we were to draw this out. Here's one ester linkage, and then we have another ester linkage right here, like this, like that. Double bond O, and then the oxygen, and then carbons coming off of that. So we call this a diester. So this right here is a diester, and this right here would be a single ester and a single ester, like that. Okay, so the reaction is very similar to what we did last time. And that is, we're going to take our water molecules here, we're going to break them apart like this, and then we're going to add them to our ester linkages here and then pull them apart. So I'm going to start out here with our ester linkages here that would form fatty acids. So that looks very similar to what we did before, okay, and that we're going to end up with our carbon like this, our carbon double bond oxygen, like that, and then here is our carbon chain, and then we would have an oxygen. And I'm not going to put an H there just yet. So I'm going to redraw this, so I'm going to have two of them here. I'm going to go carbon, double bond oxygen, zigzaggy line like this, and then here is like that. Okay, now what's going to happen here is going to be a little bit different, a little bit odd, and that is we're going to take our water here, we're going to split this apart here, and this gives us sodium, like this, sodium ions. And then those sodium ions, because they're electropositive, are going to be attracted to these electronegative oxygen atoms. So when that happens, we'll end up with sodium here, Na plus, Na plus, like this. And then this, instead of being called a fatty acid, it becomes a fatty acid salt. So I'm going to say 2 fatty acid salts. 2 fatty acid salts. And these have a fancy name. They're also called soap. Okay, and so soap is where we take a phospholipid like this and we break it down using a strong base. Okay, so that is soap. And then the rest of this is going to look fairly similar to what we did before. And that is, we're going to end up taking this phosphate ester, this phosphate diester here, and then pulling apart the linkages. Okay, so I'm going to put in my phosphate here. So here's my phosphate, like this, double bond O, like that, like that, like that, like that. Okay, now in these very basic conditions, under very basic conditions like this, the hydrogens do not end up getting attached like this. And so we end up then with these just being like that. And you might be going, what? What's up with that? Okay, so here's the deal. We had, when we pulled this apart here, we ended up with sodiums going up here. And then we ended up with excess hydroxides here, excess OHs. Okay, and those excess OHs, I'm just going to put those down here. Those excess OHs, OH like this, that would take the hydrogen from here. Okay, so I'm going to put like a hydrogen here, and that's going to come down here, attached to this, and then we end up with HOH. Okay, so that ends up giving us equals HOH, which is, of course, water. Okay, so maybe I'll just go like this. So this plus this equals water. Okay, and so that's why this phosphate group here, like this ends up with just the oxygens on either end there. Those hydrogens would get removed. Okay, and then what do we end up left with then? Okay, so we have this chain right here. That chain right there ends up becoming an alcohol, and so that would end up here being OH, and then a carbon chain like that. So we'll call this an alcohol. And then we also end up with our glycerol, the backbone here. So glycerol. So CH2CH. I can do better than this. I can do better, I swear. Carbon like this, CH, and then CH2, OH, OH, and OH, and this is our glycerol group. Glycerol, okay, so all this right here becomes glycerol. Ba-ba. That's how we make soap.